All right, so section 2.2 is subsets. Okay, so let's figure out what a subset is. It says the set A is a subset of the set B. This is how we sort of read this part. A is a subset of B. Okay, and it says A is a subset of B if and only if all the elements of the set A are also elements of set B. So before we go on, let's make sure we understand what that means. Everything in the set A can also be in the set B, okay, or also needs to be in the set B. Doesn't have to go the way of the round, but everything in the first set has to also be found in the second set. Okay, so it says the symbol A is a subset of B, the set A is a subset of B. When we have this one right here, the way we read that is it's not a subset, right? So A is not a subset of B indicates that the set A is not a subset of B. What that means is that there's got to be at least one element in A that cannot be found in B. So let's see if we can sort of make sense of all that stuff there. I know there's a lot of words, but let's see if we can make sense of that. Okay, so is the set A a subset of the set B? What we need to figure out is, are these three guys here, can they also be found here? Yes, they can. So we're going to say A is a subset of B. That's all that it means, okay? That all the little things inside the set A can also be found in the set B. Let's do the same thing for the next one. Can these four guys here, all of them, be found in here? Oops, in here? No, they can't, because 5 and 7 are not in there. So we would say here, A is not a subset of B, okay? If you notice, the other way around it would work, right? B is a subset of A because both these guys are here. But it's just asking us, number one, is A a subset, oops, there we go, of B. Okay, let's take a look at the next one. Let's see if we can figure this one out. A is a set of X such that X is a yellow fruit. B is a set of X such that X is a red fruit. So we want to know, are all yellow fruits also red fruits? Well, let's think of a yellow fruit. Let's think of, when I think of a yellow fruit, I just think of banana. Okay, would you say banana is also a red fruit? No, it isn't, right? So that means that A is not a subset of B, right? Some people might say, well, what about a mango? A mango has both yellow and red, and that's true. But as long as you can find one yellow fruit that is not also red, then it's not a subset, okay? All right, let's take a look at the next one. So we want to know, are all these three guys here also here? Well, here's time, there's time. Here's Newsweek, here's Newsweek. Here's people, yep, there's people. So yes, A, oops, is a subset, oops, come on, of B, okay? All right. Now, if you notice on this last one, guys, aren't those two sets actually equal? Because they have exactly the same elements in both of them, right? So talking about that, notice that those were equal. We have something called a proper subset, okay? A proper subset looks like this. A is a proper subset of B, so it doesn't have the little line underneath. And it says, if and only if all the elements of A are also in B, but the two sets aren't equal, okay? That is, set B has to have at least one thing that's in B that's not in A. All right, so we want to figure out here, let's see if we understand what this means. Is A a proper subset of B? So first off, is jazz here? Yes, it's in both. Pop, I need to find pop over here. Hip hop? Yes, hip hop. But as long as set B has at least one, in this case it has two, elements that are not in A, then we can say A is a proper subset of B. Okay. Now, let's do the same thing for the next one. Here's A, here's A, here's B, here's B, here's C, here's C, here's D, here's D. There's nothing left over here that wasn't over here. So in this case, we would say A is not a proper subset of B. Now, I do want you to notice that A is still a subset of B because everything in A is also in B. It's just not a proper subset. Again, in order for it to be a proper subset, this set here, B, has to have at least one more element that A doesn't. Okay. All right. So now we're going to talk about the number of subsets. Okay. So remember, this one here, this is what we call the empty set. okay? The only subset the empty set has is the set itself. That means there's only one subset, okay? Now, the set containing one element, which is the letter A, has two subsets. It has the set itself and the empty set. So there are two subsets of it, okay? And the sort of same thing happens here. The number of distinct subsets, the way we figure this out is we're always going to take the number 2 and we're going to raise it to the power n. N is going to be the number of elements in the set A, okay? And then the number of distinct proper subsets will be whatever that number was, we're going to minus 1, okay? So now, let's take a look here at part A. This is going to take us a little bit of time, so I'm going to do it in pieces. Part A says, determine the number of distinct subsets for the set containing the letters S, L, E, D. Okay, so the first thing I'm going to do, 1, 2, 3, 4. There are 4 elements in here. So the way I'm going to figure out how many we're going to have, we're going to take 2 to the power 4th. So guys, again, you can grab your calculator if you need to. Let me see, where is it? Here we go. 2 times 2, that's 2, that's 3, and one more is 4, 16, okay? So there's going to be 16 different subsets. Okay, part B is going to be the one that's going to take me a little bit of time to do. Now it says, list all the distinct subsets for the set. So let's do it like this. We're going to basically try to figure out all the different combinations, okay? So how about if the first one is S, L, E, D. That's the first set that I can make with all 4 of them. Now let's go through the ones where we can make with only 3 of the letters. S, L, and E. Oops. S, L, and D. Let's see. We have to go through all the ones that we can make with just 3 letters. L, E, and D. Okay, let me make sure we got them all. So I think that's all with 3. Now let's go with the ones for 2. 2 letters only. S and L, S and E, S and D. What about L and E? L and D. Let's see, are any other ones? S and E, S and D. L and E we already have. L and D we already have. E and D we need. Okay. Now let's do the ones where they only have 1 letter. So look, S, L, E, D. I want to do a quick count just to see how many I have so far. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm missing 2. Okay, I might be missing 1 with, let me see. Give me 1 quick second so I can figure it out, and I'll tell you which one's it. All right, so guys, I figured out the one that I was missing. I'm missing one that has 3 letters, S, E, and D. Okay. So that makes it 15. The last one is one that we typically don't think about, but it's always going to be in there. It's the empty set. There is nothing in there at all, okay? Those are all the subsets of the set for S, L, E, and D. Okay, those are all the possible combinations. Now, part C says, how many of them are distinct subsets? So I want to notice what we have here. The number of distinct proper subsets is 2 to the power n minus 1, okay? So when we did 2 to the power n earlier, we got 16. So 16 minus 1 is going to be 15. The one that's not a proper subset, guys, is the actual set itself. But all these other ones here are going to be proper subsets, okay? So now, let's take a look here. It says, is it going to be an element or a subset? We're going to see if we can figure this out. Okay, so a little slightly different from what we did before. Notice that these have the little squigglies on them, right? They got little, okay, so what we're going to say is the guy that's on the inside here, can it also be found here? Yes, it can. This is why it's true, okay? Is the word book also here? Yes, it is. Is the word magazine also here? No, it isn't. This one is going to be false. So this one is a subset, this one is not. Okay. Let's see. Look at the next one here. So guys, first thing I want you to notice is proper subset. Okay, it's asking me is there a proper subset. Gold, first let's figure out if it's a subset. Yes, it is. Silver, yes, it is. Bronze, yes, it is. I know it's a subset. Is it a proper subset? In order for it to be a proper subset, there would have had to have been one word over here that I would not have underlined. So this is going to be false because it is not a proper subset. I would have needed one other metal in here like, oh, I don't know, platinum or something like that, aluminum, tin, something in there so that it wouldn't have been over here as well. Okay. All right. Now let's take a look at this one here. Swimming. This has an element. Okay. Notice no squigglies. Is the word swimming one of the words that's here? Yes, it is. This is going to be true. Okay. Now, again, look at this. We have element, but because we have the squigglies and these individual words don't, this is going to be false, right? All right. So now it says, in the next few problems, determine whether they're equal, whether the two sets are equal, whether A is a subset of B, B is a subset of A, is A a proper subset, if B is a proper subset of A, or none of them applied. There could be more than one answer. Okay, so now let's take a look. Is A a subset of B? Can this word be found here? Yes, it can. Can this one be found here? No, it can't. So I know that A is not a subset. So if it's not a subset, they're not equal. Because number one, I can already see there's not equal. But let's do it the other way around. Is this word here, so let me erase this. Okay, let's come back over here. Oops, there we go. Is this word also here? Yes, it is. Is this word also here? Yes, it is. So number one, just come on, pen. I know that B is a subset of A, and it's also a proper subset because of the PS4. All right, now look at the next one here. It says A is a set of the natural numbers that's smaller than 6. Okay, so I'm going to think about that. Let me actually write out the set A. Natural numbers that are smaller than 6. 1, 2, 3, 4, 5. I'm going to stop there because those are the numbers that are smaller than 6. Now, let's take a look at B. These are set of natural numbers. Okay, guys, what these little parts right here mean, this is sort of that word that we saw back in 2.1. This is what inclusive, oops, come on, pen. Hold on, guys, my pen is acting up a little bit. Okay, let's see what works now. There we go. This is what the word inclusive means. So I'm going to start with the number 1, and we're going to stop all the way till we get to 5. Okay, so number 1, let's see. We know that those two sets are equal just by looking at them. And then wouldn't you also agree that A is a subset of B? And B is also a subset of A? But they're not proper subsets because they are actually equal to each other. So for this one, these would be my 3 choices, okay? Now, let's take a look at the next one. Is A is a set of sports that uses a ball. B is a set of sports, basketball, soccer, and tennis. Okay, just those 3. So I think it's clear to say, we can say that they're not equal. Okay. And I think it's also clear to say that A is not going to be, oh, come on. Why is this thing freezing on me again? Hold on, guys. Sorry about this. All right, so let's see. I think this thing's working now. Let's see. So X is a sport that uses the ball. A won't be a subset of B because I can think of a sport already. What about football? That's not one of those, right? But wouldn't we say that B is a subset of A? because basketball, soccer, and tennis are all sports that uses a ball. And then we would also say that B is a proper subset of A because there are other sports that use a ball that's not basketball, soccer, and tennis, football, baseball, golf, things like that, right? Okay, so now the next couple of problems here say list all the subsets for the set given. Okay, so we have two elements here. I'm going to abbreviate, guys. I'm going to go C and H. That's the first one. C would be the next one. H would be the next one. And the empty set. So remember, the way I'm going to figure out when am I done, I'm always going to take the number 2 to however many elements that I have here. So 2 squared is 4. 1, 2, 3, 4. Right? Oops. Okay. Now, let's do the same thing here. So I'm going to go 2, 1, 2, 3. So 2 to the third is 8. Okay. Again, I'm going to abbreviate, guys. I'm going to go steak, pork, and chicken. Oh, there we go. Okay. Steak and pork. Steak and chicken. Oops. Come back and do that quick. Oh, come on. Sorry about this, guys. Okay, we said steak and chicken. Let's see. Pork and chicken. And then one for just steak. One for just pork. One for just chicken. And then the empty set, 1, 2, 3, 4, 5, 6, 7, 8. There we go. And let's see. So the last one here, guys. Let's see if we can do this one. I'm going to try to make this, hopefully this works a little bit better. Okay, so remember, I have 1, 2, 3, 4. So 2 to the 4th does give me 16. So the first one is A, B, C, and D. Okay. Let's see, that's the first one, and then A, B, C, A, B, D. Let's see, B, C, D, and let's see, I have A, B, C, A, B, D, B, C, D. Do I already have A, B, D? Do I have B? I think that's it. That might be it for the 3. Let's go for the 2s. We'll find out right now. A and B, A and C, A and D. Let's see, B and C, B and D. Let's see. A and B, do I have B and C? Yes, I do. Okay, let's see if we can go with the singles now. A, B, C, D. I know I gotta have 16. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, I'm missing 3 more. Let's see. Well, I know one of them missing is this guy right here, the empty set. So let's see, which other ones are we missing? Do I have all the ones for the 3s? Give me 1 second so I can see if I can figure this one out. Alright, so guys, here are the other ones. I was missing A, C, and D, and C and D. And then which ones are not the proper subsets? The one that's not a proper subset is this guy right here, the one that has all of them. B, C, and D. That's not the proper subset, okay? Alright, and that is 2.2.